Hello everyone, I am Prarthana. Today I will be talking about file system management in operating systems. This is an important topic because file systems are what allow us to store and manage data efficiently. Let us imagine a world without file system where every file is just dumped into a single space without any organization. It's a big problem, right? Well, that's why operating system provides structural file management. Let's get into the topic. Firstly, introduction to file system. A file system is like a digital library. It organizes, stores, and manages data on storage devices. The storage devices or includes hard drives, SSDs, and USB drives. Without a file system, the computer would not know where one file ends and another starts. It also handles operations like creating, deleting, reading, and writing files. For example, when we are opening an PDF file, the PDF file the file system helps the operating system to locate it. It reads the content and displays on our screen. Next, functions of file system. A file system has several key responsibilities, like firstly, file creation and management. It helps in organizing and retrieving files easily. Next, storage allocation. It decides how and where data is stored on the disk. Next, metadata management. It stores information like file size, modifications, and permissions of the files. Next, data directories. It is used for ensuring that files are well structured. Next, file protection. It restricts unauthorized access. For example, on a Windows computer, every file has properties like read only or hidden. That's file protection in action. Next, what are the types of file system? We have different file systems for different purposes. Firstly, disk-based file system. For examples, NTFS, ext4, FAT32 are commonly used in hard drives and SSDs. Next, network file systems like NFS, SMB, DFS are used for allowing file sharing access across the computer. Next, flash file system like YAFFS, JFFS2 are optimized for SSDs and pen drives. Virtual file systems like Proc FS, System FS used to manage processes in Linux. Next, let's see an example for this. For example, we are our Windows laptop mostly runs NTFS while USB drive often uses FAT32 for compatibility. Next, file system structure. A file system consists of boot control block. It is used for storing information required for booting. Also consists of file control block. It maintains metadata of the file. Next, directory structure. It organizes files into a tree format. Next, tree blocks. The actual location where file content is used for storage purposes can be accessed by the data blocks. For example, when we start our laptop, the boot control block helps load the OS from the hard disk. Next, file system hierarchy. A file system has a structured hierarchy. In Unix or Linux, it starts with root directory. In Windows, it starts with C:* directory. Next, in subdirectories, it helps in better file organization. For example, in our system, C colon user document project report document. We saw in file management like that, right? That is an file hierarchy structure. Next, file operation. Basic file operation includes creating, opening, and closing files, just like writing and closing a notebook. Reading and writing data, like reading and editing a document. Appending and truncating, adding or removing content. Renaming and deleting, self-explanatory. These are the basic file operations that are done in file system. Next, directory structure. File organization depends on the directory structure. Firstly, single level directory. Everything shown in only one directory is called single level directory. Two level directory is separate user directories. They have separate user directories. Tree structure means tree structures are most commonly used in operating systems. Next, acyclic and general graph. It is used because they are more flexible and allowing shared directories. Next, file allocation methods. To store files efficiently, we use different allocation methods. There are three different allocation methods. Firstly, contiguous allocation. It is used for storing files in a contiguous block, fast but waste spaces. This is the explanation for contiguous allocation. Next, linked allocation. In linked allocation, each file block contains a pointer to the next. That means a file block points to another file block. It's used mostly because it saves the space, but the accessing speed is slow. Next, indexed allocation. Using an indexed allocation table for quick lookup, it increases the access speed. For example, NTFS uses indexed allocation for better performance. Next, file access methods. There are three ways to access files, like sequential access, direct access, and indexed access. Sequential access is like reading a book page by page. That is, we are accessing the file from one end to another end, like searching and middle of the file, but we are searching from the first page until the our target page. Next, direct access, jumping directly to a specific page. The which page we are searching for is the specific page, so we are directly going into the specific page, that is our target page is accessed by direct access. Next, indexed access, like using an index to find a chapter quickly in a book. We usually look up into the index page to find what is the page of the our specific topic, like similar to that indexed access. Next, file system mounting. Mounting makes storage devices accessible. When we are inserting a pen drive, the OS mount it automatically. Process of making a file system accessible. Mount point and mounting process. Auto mounting versus manual mounting. Next, file system protection. Security is key. Features include ACLS, which means Access Control List. It defines who can access the file. Next, File permissions. Read, write, execute process. Next, encryption. Protects file from unauthorized access. User authentication and encryption. Next, journaling file system. Journaling file system like NTFS, ext4 log files changes before applying them, preventing data loss in case of crashes. Next, file system consistency. Maintained by tools like FSCK in Linux and CHKDSK in Windows to detect and fix errors. Next, distributed file system. For example, NFS, DFS, SMB allow file sharing over a network. It improves accessibility but requiring strong security. Next, file system performance. Techniques like caching, buffering, and defragmentation help improving speed and efficiency. File system security. Security features includes user authentication, encryption, and secure file deletion to prevent data recovery. Next, file system in Linux. Linux file systems includes ext2, ext3, and ext4 with virtual file system layer for abstraction. Next, file system in Windows. Windows supports FAT32, NTFS, and EXFAT. NTFS is preferred for its encryption and journaling feature. Comparison of file systems. NTFS versus FAT32 versus ext4. NTFS is secure, but FAT32 is compatible, and ext4 is used in Linux for better journaling. Future of file system. Upcoming trends includes cloud-based storage like Google Drive, AI-driven optimization, predicting storage needs, quantum storage, the next breakthrough. Conclusion. To summarize, file systems are critical for data storage. Different file systems serve different needs. Future development will focus on security, performance, and AI. Thank you. This is our last slide.